Okay, so it says here the heights of players are at a local basketball league have a mean of 77 inches and a standard deviation of 4. And the heights are normally distributed. It says estimate the probability that a random player is at least 73 inches tall. Okay, well, again, if you look at the tables here and you're saying at least, it doesn't do at least, it does at most, and it always shades to the left. So what we have to do is we have to go and approach it with the table still. So 73 inches tall, we got to go to our z table, and we're going to calculate the z-score. So z is equal to 73, which is this individual that we're talking about, minus the mean, which is 77, over 4. Now that's a nice one. 73 minus 77 is equal to negative 4 over 4. That's a negative 1. So your z value of negative 1, if you set up your standard normal model, you're talking 1 standard deviation below average now. Okay, and so it says at least that tall, so you're looking at everything on this side of it. Okay, so it's 1 standard deviation below. It happens to be 73 inches, and that's 77, and so the standard deviation of 4. This is 34 here, and that's 50, so that would be an 84% or bigger. But let's use the tables for just a second if we pretend we didn't know what the empirical rule meant. Okay, you go to negative 1, which happens to be down on this one here. If you go to negative 1 is right here. Okay, so negative 1, let's see if I can light that up a little bit more. Okay, negative 1, 0.1587. Okay, now that doesn't match what I put here. So 0.1587 is really close to 0.16. Okay, but again, that just gave me that zone in there. That zone is 0.16 if I round to 2 decimal places. Okay, so if we're saying at least and it's saying that more than, we have to consider going that direction is the rest of it. So we're taking 1 and we're subtracting 16. That's where I got the 84%. Okay, at most 81 inches tall, basically going to the other side of that image there. Okay, so if I say at most 81 inches tall, now we're saying 1 standard deviation above average, and that's this. And so there's your 81, 4 units above. Again, if you do the calculations, it's 81 minus 77 over 4. That's equal to 4 over 4, which is equal to 1. So it's 1 standard deviation above average. At most, though, applies to what the tables are going to tell you. So if you look at your table now, at most, we're going to positive 1. So that means that much or less. There's your 0.84. So if you go to 2 decimal places again, 84% are going to be at most 81 inches tall. Now between 69 and 81, we're back at this again. Now if you go back and if we're looking at this again, forget the tables. Between 0.69, there's another 4 units. Now we're looking at the empirical rule again. 68% is within the 73 to 81 with your additional 3.5% or 13.5%. 68 plus 13.5% is an 81.5% fall within there. And at least 85 inches tall. At least 85 means 85 or more. Well, 85 is up here. That's 2 standard deviations above. So we can do all these with the empirical rule. At least 85 inches tall, you're looking at however many are more than 2 standard deviations above average. Remember, 95 fall within 2 standard deviations. 5% then is on the outside, split in half. So this is 2.5%. And so the z-score of a player who's 83 inches tall, we did these z-scores earlier, that was probably overkill. 83 minus 77 divided by 4. 83 minus 77 is 6. 6 over 4 is equal to 1.5. So your z-score is 1.5. Now, finally, we can use this. What's the problem of randomly selected players? At most 83. So according to the table, it always does at most anyway. 1.5 is this right here, and that's 0.9332. So if you say 0.9332, that's the probability. You can also call it 93.32%.